Here I'm showing you some of the answers for the homework so that you can check your work and maybe learn some things about how to do it better. We're looking to draw dot structures for molecules. If it's ionically bonded, it's a lattice. Octet rule is the rule of 8, and a line structure can also show the bonding in addition to dots. Name the molecule. So there's 4 things to do. I'll show a few of these. Starting with number 6. I will draw the dot structure. I'll draw the line structure. I will discuss some common errors. Start with carbon. Carbon is in column IV, which is Roman numeral for 4. So that means 4 valence electrons. That means 4 dots. Common mistake is for students to put dots something like this. This is not what you want to do. You want to spread your dots out around a square table. So if you did this, then get out your eraser and start over. One, 2, 3, 4. That's how you arrange 4 dots. The next common error. I'm going to add some hydrogens. Students tend to do this, where they say, okay, I'll make my hydrogen really small and stick it on the corner here. And that's not what you do. The hydrogen is an invited guest to the dinner table. The hydrogen is big and proud and is sharing 2 electrons. 1, 2. Not attached to 1 electron. Sharing the pair. Sharing the pair. So instead of these little tiny hydrogens, make them big, proud hydrogens. And not on the corners. We should be able to see a nice square table. Nice square table. There. There's only 1 slot left to fill here. If you put the 4th hydrogen, if you take this hydrogen here and you stick it on right here, that'll be it. There's no place to put the oxygen. So instead of doing that, you want to put the oxygen next. This is hinted at the way it's written. CH3 and then an O and then an H. Here's an O. How many dots for an oxygen? Look at the periodic table. Column VI is Roman numeral 6. So 6. 1, 2, 3, 4, 5, 6. You'll notice I've used all 4 sides of the table. And there's 1 slot left to fill. That's what this hydrogen here is for. Hydrogen. Okay. That is the dot structure for CH3OH. I will now turn it into a line structure. To do a line structure, wherever there was a shared pair, like right there, or right there, that becomes a bond. So I see carbon bonded to a hydrogen on the left, carbon bonded to a hydrogen on the bottom, carbon bonded to a hydrogen on the top, carbon bonded to oxygen on the right, oxygen bonded to hydrogen on the right. This is the line structure. The name. It will make more sense when you have all the structures that you'll start seeing patterns. But one of the common words in these naming these molecules is methyl. Methyl. You see it in the word bank. Methyl. Dimethyl. So this is a structure that is present in more than one molecule. And when you see the word or the prefix di, you should think, that is the structure repeated within the same molecule. So this one happens to be methyl, which refers to the CH3 group. This CH3 group right here is very common, and because it's common, it gets a name, methyl. The last name is alcohol, and it will turn out that anything that has this structure with the OH is an alcohol. So the name is perfectly logical. In the beginning you might say it's gobbledygook, but it is a logical description of this molecule. Methyl, CH3, alcohol, OH. Okay, the next one I'm going to do for you is number 4. Number 4 is not a molecule. Number 4 is an ionic substance. Calcium is a metal. Oxygen is a non-metal. You will recall that a metal plus a non-metal makes a salt. Salts are not covalently bonded, they're ionically bonded. Salts do not get dot structures. We've drawn calcium oxide since September. Don't change it now. So, here's a reasonable picture for calcium oxide. Ca will be a 2+ ion. If you understood the interactive physics simulations, ionic substances make lattices made of positive and negative ions. Calcium will be a +2, oxide will be a -2. There are no shared electrons here. It is an ionic lattice. Don't draw it at all like number 6, which is covalently bonded molecule. The pictures shouldn't look at all alike. This is calcium oxide. You knew how to name it in September. It hasn't changed its name now.